Hi everyone. So this video is going to help you learn how to do these last two problems on the packet that are going to be turned in for homework. So this first one is about the distance between a parabola and a point. So I'm first going to graph that real fast so you can see it. And I think you might have the graph on your paper already. It's just not very visible. So we have the parabola x squared minus 8. So that's just a parabola that's been shifted down 8. Let's get a different size here. So here's my negative 8. And here's my parabola. And then I want to know the distance from the parabola. So where would you put a point on the parabola that its distance to the point 0, -1 would be a minimum, so it would be the smallest. So we're looking for some random point. I'm going to call it xy. That, again, when I find the distance from that point xy to the point 0, -1, this distance is, it says, the smallest, so we're going to think minimum, okay? So you need to write an equation for the distance between 2 points. So hopefully you remember that formula. If you don't, here it is. So the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So with the 2 points I have here, this becomes square root of x minus 0 squared plus y minus a -1, so y plus 1 squared, okay, distance. When we put this in the calculator to graph this, we obviously have to have everything in terms of x, and we're going to replace the d with a y. So I need to get rid of the y in this formula here. And that y comes from the description of the problem where we started it. So if you notice up here in the very beginning of the problem, it already told us what y was equal to. Y is equal to x squared minus 8. So now my formula becomes x squared plus y is x squared minus 8 plus 1, the whole thing squared. So I'm replacing the d with a y, replace the y with this x squared minus 8, and I now have this. Oops, that's a 7 squared. Okay, so you need to put that in the calculator and find the minimum. Depending on the window on your calculator, it's actually going to be hard to see. So I'm going to go ahead and show it to you on Desmos. It'll be a better view. So here is our Desmos graph. Okay, so you can see that it's going up and down like this. Now note, I did not, when I started the problem, create a domain restriction because when you look at the graph here, technically there is no domain restriction. You can put your x anywhere you want on the graph. So there is no domain restriction on the x. It just, since you're finding a minimum, you're going to be looking for the lowest value on this graph after we graph it. So going back to Desmos here. So here are our two lowest values. Desmos is always nice to us. So if you just click on it, you can then see the two values. Notice they're the same. Just one's positive, one's negative, because one's on the right side of the y-axis and one's on the left side. So we could say that x is equal to 2.55 or x is equal to negative 2.55. Okay, let me go back here and we'll write those down, and that is the answer to our question here. Okay, moving on to question 7. And of course, don't forget, you can pause anytime you need to write things down. All right, so this problem is a box with a square base. So square base, no top. So it says that the tank is to hold 1,000 cubic feet of water, so that's your volume measurement. And it does also say to let x be the length of the base. So I'm going to let those two pieces be x, and then we'll call that side the height. So I'm going to start by writing a formula for the volume. So the volume will be area of the base times the height, or x squared h. And since the volume is 1,000, I get x squared h equals 1,000. And I'm going to need h by itself. So I'm going to rewrite it as h equals 1,000 over x squared. Then it says find the length, the width, and the height of the tank if the outside surface area is 600. That just means don't include the inside of the box, only find the surface area of the outside of the box. And my surface area formula then, since this has no top, will be the 1 base of x squared and the 4 sides that are each x times h. So now I can substitute in what I found for h. So 4x times 1,000 over x squared. And this simplifies to x squared plus 4,000 over x. Okay, so this question is a little bit different than the ones we've been doing in the past. So part A asks you, so let me take a step back. In previous problems, what we would have done is found the minimum surface area. Okay, so that would have been what you've been asked. But now you're being asked, find the length, width, and the height of the tank if the outside surface area is 600. So we're actually putting a 600 in for the surface area. And you can now solve this in one of a couple of ways. You could just do some algebra. So do it algebraically by hand, which I am not going to do, but you could. Okay, so multiplying by x to clear out the fraction, and you would have some cubic function that you'd still have to deal with. So instead, I'm just going to put, if I was using my calculator, I would put in for y1, 600, and in for y2. Okay, so y1 and y2, and then you would find the intersection. So you would find the intersect on your calculator. It's just so complicated to do that right now, and I want to keep the video short. And I'm going to go ahead and use Desmos again. So let me get rid of this thing, and I will show you this function and show it equal to 600. So here is my surface area formula, and here is what I want the surface area to equal. So I need to scroll out so that I can see where this is happening, because this is a fairly large number. Well, I have to at least see 600. So here it is. Let me make that zoomed in though. Okay, so again, in previous problems, I'd have asked you for the minimum, and here's the minimum on the graph. So the minimum surface area occurs here at 12.599, but I am asking where is the surface area equal to 600? So I have to go to 600 on my graph and look at the intersection. So you can see that there are 2 places that this happens, at 7.321 and at 20. So let me go back to my screen here. So it's equal to 600 at x equals 7.321 or at x equals 20. Okay, well now I want to find the heights, because the problem did ask for the length, the width, and the height where this occurred. Well, we've got the length and the width. So now to find the height, we have to use that formula that was 1,000 over x squared and substitute these 2 values in. And I'm going to go back to Desmos and show you what I did there. So on Desmos, I set it up already. So over here in this spot here, I called the height for h 1,000 over x squared. And then I can just have it calculate it for me. So h of 20 is 2.5. And then I want that 7.321. That is 18.658 approximately. So back here, this height is 18.658. And this height is 2.5. So this would be a very short box that's really wide and long, but short. This one would be significantly taller, so it'd be a tall box that is not very wide or long. Okay. Part B then asks you, get a different color here, to find the range of values, basically. So it says, scroll back up. What dimensions are possible for the tank if the outside surface area is to be less than 600 feet? So when I look back at the Desmos graph, zoom out just a little bit. So this whole region of the graph is when the surface area is below 600. So this whole piece of it. So we just want an interval from this x value to this x value, which we already found them. So the surface area is less than 600 when the sides of the base are between 7.321 and 20. So the answer to part B is pretty straightforward because we already did the work. So when x is between 7.321 and 20, then the surface area will be less than 600. And then h would have to correspond. H would have to be between 2.5 and 18.658. Okay, hope all that makes sense. Please make sure you ask us questions if you have any.